Okay, let's continue the. Okay, so if we try to use the Jacobi method to solve the problems, first we need to search all the off-diagonal elements to find the element with the maximum absolute. For example, if the if Aij is the maximum absolute, then we will try to multiply the A by the T and the T transpose. And the T matrix will use the cosine theta, negative sine theta, sine theta, cosine theta. Okay, and in the advanced structural theories, actually I will call this matrix, which is the R transpose matrix. And in that course, I define the R times the original element can give you the elements or the vector components in the new coordinate axis. Okay, and since originally the A matrix, which is multiplied by the AI and AJ, they are follow the original definitions. After we multiply the T matrix, we like to use the new vector components, AI prime and AJ prime. But so you can say we need to multiply the R transpose. Okay. However, in this course, I will call this one is the T matrix. Okay. Okay, so it is only the name of a matrix. Okay, also remember for this rotation matrix, the T transpose also equal to the T inverse. Okay, since it is very easy to prove the T transpose is also the T inverse. And the T inverse multiply the A and multiply we can get a new matrix. Let's say that that's the A double prime matrix. And the A double prime matrix can be called the A double prime matrix, which is called similar transformations of the A. Okay, if we pre-multiply the T inverse, post multiply by the T, and then we can get a new matrix. The new matrix is also called the similar transformation of the old matrix. Okay, and also you can find from the engineering mathematics textbook, you will find the theorem. The similar transformations will have the same eigenvalues. So the eigenvalues of the original A matrix will not be changed if we make the similar transformations. So if we follow the Jacobi method, if we pre-multiply the T transpose, post-multiply by the T matrix, then it is also similar transformations. For the similar transformations, the eigenvalues will not be changed. Okay, so it is is also a theorem. Okay, so let's try to get the formula. So let's calculate the A prime first. A prime is defined by the A times T matrix. So let's try to finish the A multiplied by the T matrix. And the post multiplied matrix sometimes is called the column operations. Okay. So in this one, which is also called the column operations. Okay. The post multiplied matrix, which will make the original A prime, and only the ith column and the jth column will be different. Okay, since all other elements in the diagonal elements, they are all equal to 1. All the off-diagonal elements, they are equal to zeros. So it is very easy to prove it by yourself. So you will find the A prime. If we compare the A prime matrix with the original A matrix, you will find only the ith column and the jth column will be different. And also you can understand why the post multiplied T matrix, usually we will call they are the column they are the column operations. And what is the new ith column? Will be equal to the cosine theta times the original ith column plus sine theta times the jth column. Okay, so you can prove it by yourself, and since it is only the basic definition of the matrix multiplications, if we try to post multiply the T matrix, the new ith column will be the original ith column multiplied by the cosine theta plus the sine theta times the original jth column. So you can get the A Li prime is equal to cosine theta times A Li plus sine theta times A Lg. Okay, so the new elements in the ith column. Okay, the ith column we can control the second subscript. The second subscript is always equal to the I, so it means the L is a variable. The L can be changed from the 1 to the n, and for the elements in the ith column is equal to the cosine theta times the elements in the ith column plus sine theta. Okay, also it will be changed the AL J prime is equal to negative sine theta times ALI plus cosine theta times ALG. Okay, so the new jth column will be equal to the negative sine theta times the original ith column plus cosine theta times the original jth coordinate. Okay, so these two formulas will represent the the new elements of the A prime, and all other elements they are same as the original A matrix. Okay, so that's the T matrix. And what is the T transpose? Okay, the T transpose, it is the T transpose II is equal to the cosine theta. T transpose JJ is equal to the cosine theta. And the T transpose IJ is equal to the sine theta. T transpose. Okay, and also let's say the A double prime is equal to the T transpose times now the A prime. Remember, the A prime is the A times the T matrix. And let's calculate the A double prime elements. And right now, the pre-multiplied matrix, the T transpose matrix, the pre-multiplied matrix represents the row operations, So the ith row of A double prime will be equal to the cosine theta times the ith row of A prime plus sine theta times the jth row. Okay, so if we pre-multiply the T transpose to the A prime, so only the ith row and the jth row will be changed. Since all other elements, they are same as the union matrix. So the first row, the second row, as long as they are not equal to the I or J, they will not be changed. Only the ith row of the A double prime will be different from the original ith row. And also we can prove the ith row of the A double prime is equal to this one. And also you can use a formula. So the L is a variable. The L represents the values. It can be changed from 1 to the n. It can be changed from the 1 to the n. And the new so this formula represents the new ith row will be equal to the cosine theta times the corresponding element in the original ith row plus sine theta times this one. And if we like to calculate the new Aij double prime, it is equal to the cosine theta times Ai L prime. And what is the Ai L prime? Times Aij prime plus sine theta times a j j. Okay. Since that's the general formula for the ith row elements, but right now I like to calculate the particular element, which is the aij double prime. So it is a formula for the entire line. That's the formula only for the element, the aij double prime elements. So it will be the cosine theta times, if we replace the L by the J, that's the general formula for the ith row element. But right now, if I like to get the particular element aij double prime, so I will change the L by the J. So there is the cosine theta times aij prime plus sine theta times ajj prime. Okay. How can I get the aij prime and the ajj prime? Then I can use the second formula. To get the aij prime and the ajj prime. Cosine theta times the j as the element, negative sine theta times aii plus cosine theta times aij. That's the aij prime. That's the aij prime. We can get it from the second formula here. And also I need to add the sine theta times negative sine theta. I need the ajj prime, so times aji plus cosine theta times ajj. Okay, so I use the second formula here to calculate the aij prime and the ajj prime. Again, the aij prime, I will replace the L by the I, so it will be the negative sine theta times aii. Now the aii is the original ai. Okay, the prime means the a post multiplied by the t. That's the matrix prime. So if I use the symbol aii, it represents the original aii element. That's the original aij element. Okay, again, I like to get the ajj prime. Then I need to replace the L by the J. So it is equal to the negative sine theta times aji element plus cosine theta times ajj element. Okay. Actually, I'm doing the double check of this formula to see whether it is correct. Okay, then I will erase the unnecessary part of the blackboard. Okay, so that's the aij double prime. And remember the purpose of these transformations, we like to make the aij double prime equal to 0. Okay, so it is the aii negative sine theta and cosine theta. And also remember the aij is equal to the aji. since we have assumed the A matrix is a symmetric matrix, so the AJI is equal to the AIJ. So so in this formula, we can use the AIJ, and we can combine this term and this term, which is equal to the cosine squared theta and sine squared theta. And the AJJ is the sine theta, cosine theta equal to 0. Okay, so I just multiply the values into to get this one. And also remember the sine 2 theta is equal to 2 sine theta cosine theta. Cosine 2 theta is equal to cosine squared theta minus sine squared theta. Okay, so that's the formula for the triangular elements. And so in this formula, which can be changed to by the 1/2 sine 2 theta times AJJ minus AII plus cosine 2 theta times AIG equal to 0. Or we can move it to the another side of this one. So the negative okay. Also, let's see. Okay, so the negative sign, I will use the negative sign to change the two terms in the parentheses. So you will see the AII minus AJJ, AII minus AJJ, which is negative, AJJ minus AII. And I can divide the cosine 2 theta to both sides, so I can get the cosine theta on the left side. And also I can multiply the 2 to both sides, so you will see the 2 on the right side. And also I divide this element to the left, to the right, so you will get this one. And from this two, you can say this the tangent to theta is equal to the 2AIJ AII minus AJJ. Okay, so that's the tangent to theta. Then we can solve the theta. So what will be the theta? Theta is equal to 1/2 inverse tangent of 2AIJ AII minus AJJ. Okay, after we find the theta, that's the derivation of the theta. if you solve the theta from this formula, then you can get the T matrix. Then you can get the T matrix. Use the theta to form T and the T inverse, T transpose. Then we can calculate. T transpose A B to make Aij equal to 0. Okay, so after we search, after we find out the Aij element, which is the maximum absolute of the matrix, then we can calculate the theta. You need to use the two corresponding diagonal elements, Aii and Ajj, and also the found Aij element. That's the element with the maximum absolute. Then you can calculate the theta. Then you can form the T matrix. Then you need to calculate this one to make the Aij double prime equal to 0. Okay, so but it is only the first step of the Jacobi method. It is only the first step of the Jacobi method. Since for this matrix, you can say the right now the original maximum absolute of diagonal elements has become to 0. But actually, the purpose of the transformations that's the first step. We need to find the off diagonal element with the maximum absolute, and we can make these transformations. And after we in this step we make the maximum absolute elements, which is equal to 0. Then we need to repeat the same procedure for the next cycle. So we need to search for the maximum absolute for the final matrix obtained from this procedure. And let's say right now the AMN, which is the maximum absolute. Then we need to calculate the theta and to get the T matrix. And the T matrix is called the T2 matrix. Okay. If the AMN right now, it is the maximum, the element with the maximum absolute. And the M and the N is not possible for the I and J. Okay, since after this procedure, the Aij is equal to 0. So the AMN must be some other element. It must be some other elements. And the AMN represent the maximum absolute after the first step. Okay, so we can use then we can use the search AMN to calculate the T2 matrix. And we need to calculate the T2 transpose times the modified matrix and post multiply by the T2. Then we can get the AMN equal to 0. Okay, but when we make the AMN equal to 0, the AIJ will become non-zero. Okay, since we need to make the column operations and the row operations, and the column operations and the row operations will also affect the AIJ element. So the AIJ element, which is the maximum absolute for the original A matrix, after the T1 transpose AT1, we can make AIJ equal to 0. So in the second step, we will find the AMN, which is the maximum absolute. And we will do the T2 transpose times the center matrix post multiplied by the T2. And in these operations, we can make the AMN equal to 0. But the first element, AIJ, when we, in the first step, we make it equal to 0. In the second solution step, it will become non-zero again. Okay, so you should not expect the Jacobi method can be finished in the limit cycles or the limit steps. We can get all the off-diagonal elements equal to zeros. If you use the Jacobi method, okay, so, but you can expect the AIJ element will become smaller and smaller, since no matter the angle of the theta, the cosine theta and the sine theta, they are always less than 1. The cosine theta, no matter the angle of the theta, the cosine theta and the sine theta, they are always the values less than 1. So the multiplication of the T2 transpose and the T2 will always make smaller values than the original. So the maximum absolute will become smaller and smaller. But you need it is possible for you to you need to repeat the cycles many times. Okay, so let's say after many cycles and many procedures will be approached to a diagonal matrix. Okay, so after many iterations for the solution procedures, you will make the off-diagonal elements smaller and smaller. And finally, after many solution steps, the obtained matrix will close to the diagonal matrix. Okay, so I will take a break here, and I will continue in the next hour.